Hello, this is Rick Powers from Western Technical College for Introductory Statistics. Working on hypothesis testing for two proportions. Consider this situation. A survey was done of students at a four-year college. Out of 120 students who had no children, 52 said they planned to go to grad school. Out of 45 students who had at least one child, 28 said they planned to go to grad school. It seems reasonable that students with children would be more interested in grad school to support their families. So then, is there evidence that the rate or proportion of plans for grad school for students without children is less than the rate for students with children? Use alpha equals 0.05. Step 1, determine the hypotheses. Note that it is important to keep track of the order in which our samples are given. The first sample is no children, which is expected to have a lower proportion. There are two ways to write the hypotheses. Here's the first option, directly comparing the proportions. Null hypothesis P1 is equal to P2. Alternative hypothesis P1 is less than P2. Here is the second option using statistical traditions. Null hypothesis P1 minus P2 is equal to 0. Alternative hypothesis P1 minus P2 is less than 0. Step 2, verify the conditions of the test. We will skip this step. Step 3, calculate the test statistic, the test value. Step 4, calculate the p-value. These two calculation steps can be done using SALT. Here's the link to SALT. Note that this is done with inferential statistics. Under procedure selection, choose two sample proportion. So we will go there. We are using inferential statistics, and we click two sample proportion. Next, fill in the information from each of the samples. Each sample has a number of successes and a larger number of total observation or trials. For our situation, the one with no children had 52 out of 120, so we put those numbers in there. And then with children, it was 28 out of 45. Make sure the hypothesis test button is clicked. The hypothesized difference comes from the null hypothesis, which is 0. Indicate the direction of alternative hypothesis. In this case is less than. Click Generate Results. Note that SALT gives us the null and alternative hypotheses. The Z statistic is the test value. It is a description of how far away our sample number is from what we would expect if the population followed the null hypothesis. In this example, the test value is about negative 2.16. The p-value refers to the probability of having an extreme sample based on our sample information. It's the area in the tail of the distribution, in this case, the left-tailed area based on a z-score of negative 2.16. That area is very small, 0.015. Step 5, draw a conclusion and interpret the meaning. Since the p-value is less than alpha, we reject the null hypothesis. Therefore, there is enough evidence to prove the alternative hypothesis. Stated in the terms of the problem, with 95% confidence, there is enough evidence to prove that the population proportion of planning for grad school for students without children is lower than the rate for students with children.